All right, welcome to week 3. No cool music. I didn't come up with anything. But I do have an agenda for you, and I do have some math, and I do have some to dos for you. So, our agenda, we're going to talk about math in the real world. We're going to talk about what do you notice, what do you wonder, what would you change. We're going to talk about section 6G, which is solving exponential equations using logarithms, and 6H, which is logarithmic functions. Our to-dos this week include the Google form, answering questions and submitting work just like normal. I am going to open a Schoology quiz. It is going to be over section 6A through 6F. Part of it is fill in the blank, part of it is multiple choice. Why a quiz if grades are hold harmless? Well, most of you are doing the work. As when I looked this morning, there were 16 of you that submitted work for this unit, so there's 6 short. And I'll be emailing later today or tomorrow those people that I haven't heard from this week. But a lot of you have perfect homework, and that's where those values are going. They're going into a formative assessment category. But there are a number of you who have quiz scores that are not maybe as good as you would like them to be. So I've created a Schoology quiz. It goes through section 6A through 6F. A lot of it is rewriting. A lot of it is making sure we understand those rules of exponentials and logarithms. I'm going to open it from Thursday at 12 a.m., so that's like Wednesday night when I'm asleep, to Friday night at 11:59 p.m. So it'll be open all day Thursday and all day Friday for you guys to do. Please, 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 please note, if you can't get on during this 48-hour period of time, please, please, please email me, contact me, let me know. We can chat about additional time if you need it, or a different time that you are able to get on it. But I'd like to keep it open just for a shorter period of time as opposed to the whole week. But again, if you do have issues with it, you need to let me know. Please reach out. You guys know where to find me. Remind, email, Zoom, etc. All right. So before we get into the math, in talking with the department and talking with Miss Inchidi, there are definitely some struggles going on with the distance learning and with office hours and people overlapping with office hours, etc. I have a lot of office hours. However, math has been assigned office hours, official office hours on Thursday afternoons. So we are supposed to have office hours from Thursdays from 12:30 to 3:30. They said I'm gonna go 1 to 3. So these are my official math office hours. However, I'm not going to deny you guys getting on and asking me for help at other points in times, as long as it doesn't conflict with you getting online and asking for help with your other teachers. I hoped by creating, I had 6 hours during the week that you guys could get on and get help. Now I actually have 7. I'm not going to go away and say you can't get on Tuesday, Wednesday, or Friday. But Tuesdays and Wednesdays are being set aside for other departments to have office hours. And if you need to go there, please go there. I am not telling you that you need to get on any office hours. And in fact, in all reality, if you don't need the extra help, you don't need to get onto the office hours unless you just want to pop on and say hello, which you are more than welcome to do because I do miss seeing your faces and having conversations with you. But my official office hours are Thursdays from 1 p.m. to 3 p.m. If you have other courses that you need to get help with on Tuesdays and Wednesdays, please go to there. But I will have additional hours on Friday from 10 to 11 and 2 to 3. I'm going to keep Mondays free from office hours. However, please know if none of these office hours work for you and you can't get on before 3 and you can only get on at 7 o'clock at night, please email me. Let's chat. We'll find out a time that works for you guys to maybe get some extra help that doesn't fit into these official office hours. But official office hours, Thursdays, 1 p.m. to 3 p.m. Again, I am open to additional office hours by help. So if there is something that you need, please let me know. So, y'all know I'm on Twitter. And I saw this sign the other day on Twitter. Actually, a math teacher posted it because, we're math teachers and we're math nerds. And when I see numbers on signs and things like that, I want to process them. So, what do you notice about the sign? what do you wonder about the sign? Is the sign mathematically correct? Why or why not? And then, is there a design for a better sign that you could have? These questions are actually in the week 3 assignment upload, so you can actually answer them there, and we'll talk about them next week. So, all right, let's get into section 6G and 6H. Last 2 sections in this chapter. So 6G, solving exponential equations using logarithms. In a plentiful springtime, a population of 1,000 mice will double every week. Wow, that's a lot of mice. The population after t weeks is given by the exponential function p of t is equal to 1,000 times 2 to the t. How long will it take for this population to reach 20,000? Now, we've looked at equations like this, and I've asked you to solve equations like this, and you've used technology to solve them. Most of you needed to use some sort of graphing technology. Now that we've actually studied logarithms, we can actually look at these and look at them from a logarithmic standpoint. So, taking our function p of t equals to 1,000 times 2 to the t, how long will it take for the population to reach 20,000? So that 20,000 is going to be p of t is equal to 1,000 times 2 to the t, right? So if we wanted to start solving this equation, we need to isolate the exponential first. So we need to isolate this piece to get t out of the exponent. So you're right, we're going to divide both sides by 1,000, and that's going to give me 20 is equal to 2 to the t. Now, can I rewrite 20 so it has a base of 2? No. But I could rewrite this as a logarithm, couldn't I? Yeah. Right. You're right, PK. You could write the log base 2 of 20, because again, that's the answer, is equal to t. But wait a second, we don't have base 2 on our calculator. Well, actually, some of us do. We have that. Or we could use the change of base formula, which would be t is equal to the log of what we were taking. We're going to go base 10, divided by the log of the base, which is 2. New base is base 10 that we used. Again, we could actually enter this into our calculator, and we would say that this is log of 20 divided by log of 2, or 4.322. So that's how many weeks it would take to double for the population of 1,000 mice to reach 20,000. Wow, that's really not that long. That's a lot of mice. Can we rewrite the function for t in terms of p, which determines the time at which the population p is reached? Absolutely. So p of t is equal to 1,000 times 2 to the t. We're going to divide both sides by 1,000. So 2 to the t is equal to p of t divided by 1,000. And now we're going to use the logarithm to rewrite t is equal to the log of p of t divided by 1,000 with a base of 2. So we can rewrite it as a log function. I wonder if there's an easier way to do this. Well, you're probably right. So I want to solve the equation 2 to the x is equal to 30 exactly. Now, exponentials and logarithms are one-to-one functions, which means that we can take the log of both sides. So 2 to the x is equal to 30. Now, in previous sections, we would say, okay, log of 30 base 2 is equal to x, and then we need to use the change of base formula to rewrite x as log of 30 divided by log of 2 with base 10, or you could say ln of 30 divided by ln of 2 with base e. But that would give us our values of x. Well, the cool thing about exponentials and logarithms is because they are one-to-one functions, I can actually just take the log of both sides. Because what happens when I take the log of both sides is I use my rules from last time, and my exponent x goes in front. So I get x ln of 2 equals ln of 30. I'm going to solve for x. I'm going to divide ln of 30 divided by the ln of 2. It is the same equation by rewriting it using logs and then using the change of base formula. So that's an exact answer is ln of 30 divided by ln of 2. The approximation would be 4.907. So again, remember, you can always press pause, try to solve the equations on your own, and then actually watch the video to verify your answers. All right. Now, you can use base 10, you can use base E. I tend to use base E, again, like I said, instead of base 10 because log is 3 letters and natural log is 2 letters. So if I'm going to look at this one, I'm going to say e to the x is equal to 30. Means I'm just going to say e to the x is equal to 30. I'm going to take the natural log of both sides, right? X comes in front. We have ln of e equals the ln of 30. Now, the cool thing about using natural log when you have a base of e is the ln of e goes to 1, okay? So not 0, but goes to 1. So that for x is equal to the ln of 30. That would be an exact answer. Now, when we look at letter B, the issue is we can't take the ln of both sides until we get the exponential by itself. So in order to get the exponential by itself, I need to have this e to the x over 2 alone. So in order to have that happen, I need to divide both sides by 3. E to the x divided by 2 is equal to 7. Now I'm going to take the ln of both sides. Okay, don't put the ln at the end because ln is the function. It's not like you would write 3 and then a square root symbol when you wanted to take the square root of 3. So you're not going to do that. That's bad math. So that gives me x over 2 equals the ln of 7 because, again, this comes out front and the ln of e is 1. So then we're going to multiply with both sides by 2. X is equal to 2 ln of 7. Or you could rewrite it as the ln of 49. Either way. I like 2 ln of 7 personally. All right. Example 4. PK. There's more than one e to the x. One's e to the negative x. Plus there's a 2. You just told me that I needed to isolate the exponential. You're right. I do need to isolate the exponential. So I'm actually going to move. And I'm actually going to keep my e to the x. I'm going to keep my 2. And I'm going to move the 3 e to the negative x to the other side and set it equal to 0. Now it's a trinomial. Oh, I wonder. What would happen if I distributed an e to the x to both sides of the equation? You're right. The right-hand side would stay 0. Awesome. But distribution. What's e to the x times e to the x? You're right, e to the 2x plus 2e to the x. Now what happens when I multiply e to the x times 3e to the negative x? We agree, 3 out front. But what happens with the negative x and the positive x? We end up with e to the 0, and e to the 0 is 1, so we end up with 3. So we end up with negative 3. Wait a second. PK. This is exponentials. This is what we were talking about last time when you said we could factor it because you told us that quadratics are your friends. And IB really, really likes those quadratics. You're right, PK. This is a quadratic. In fact, I can set this up as 2 sets of parentheses. E to the x, because e to the x times e to the x is e to the 2x. That gives me my first term. 3 can be broken down into 3 and 1. But I need them to add together to give me positive 2. So I need a positive 3 and a negative 1. But now I have a times b is equal to 0. Therefore, a equals 0 or b equals 0. All right, e to the x minus 1 equals 0. E to the x plus 3 equals 0. E to the x is equal to 1. Or e to the x is equal to negative 3. But we've already talked about exponentials cannot equal negative numbers. We have an asymptote at the horizontal line. So that means this one gives me no solution. Right? And this one, I'm going to take the ln of both sides. So x is equal to the ln of 1. And if I put ln of 1 into my calculator, I'm going to get 0. So x is equal to 0 is my solution. Good job. You guys are like remembering the stuff from previous things. All right. So what's going to happen is you might see a problem that looks like this. Find the exact points of intersection. Check your solutions using technology. So using technology means we're probably going to graph things and find a decimal approximation. Find exactly the points means that you're going to not have decimals. You're going to have a natural log of some sort. Well, if we want these two equations to be the same, that means this and this have to equal each other. Oh. E to the x minus 3 equals 1 minus 3 e to the negative x. Hey, that looks just like the previous problem we did. You are correct. I'm going to keep my e to the x. I'm going to make it minus 4 plus 3 e to the negative x equals 0. I'm going to multiply both sides of the equation by e to the x, change it into a quadratic. So change it into a quadratic, factor it. Negative, negative, that's how I'm going to get negative 4 in the middle. Set them both equal to 0. E to the x minus 3 equals 0. E to the x minus 1 equals 0. E to the x is equal to 3. E to the x is equal to 1. Take the natural log of both sides. Twice. So x is equal to the ln of 3. And x is equal to the ln of 1, which means x is equal to 0. Now, you could use your technology. You can go to your Desmos, just like I can. And you can still see it because I'm screen recording, which is really kind of cool. And then I actually have notes so I can see my equation is function e to the power of x minus 3. Oh, what did that do to the function? Oh, it shifted it down 3. Interesting. And then y equals 1 minus 3 e to the x. Okay, so that one's a reflection over the x-axis, and it's shifted up 1, and it's stretched by 3. But what we can see is that my two values are negative 1.099, which is approximately the ln, let's just type in ln of 3. ln of 3 is 1.098. So there actually is our two values. You can see 0, negative 2. So 0 is the one x value, and negative 1.099 is the other x value. Interesting. Oh, no. What's wrong? Did I type something wrong? Those are our two values. What the heck? Okay. All right. So, next one. We now have insects plaguing us. We had mice, we have insects. We could do something like this with COVID. I just don't want to think about that one, so we're going to stick with insects and mice. A of n is equal to 1,000 times 2 to the 0.7 n, where n is the number of weeks after the initial observation. Use technology to sketch a graph of A sub n, hence estimate the time that it takes for the affected area to reach 5,000. You could do that, but let's go ahead and actually solve it. So we know 5,000 is equal to 1,000 times 2 to the 0.7 n. So I'm going to divide both sides by 1,000. So 5 is equal to 2 to the 0.7 n. I'm going to take the natural log of both sides or the log of both sides. Either way, you could use log base 10. So log of 5 is equal to 0.7n times the log of 2. Divide both sides by log of 2. So 0.7n is equal to log of 5 divided by log of 2. N is equal to log of 5 divided by 0.7 log, not nog, log of 2. This is why I like ln's better. They're just shorter to write. Okay? All right. Logarithmic functions, because now we actually need to be able to graph them, which I just briefly mentioned when we were looking at that Desmos. Exponential decay happens when your a value is between 0 and 1. Exponential growth happens when your a value is greater than 1. Logs are inverse functions, so that means your x and your y switch places. So if your x and your y switch places, it's a reflection over the line y is equal to x. So they actually end up looking like this. So 1 over a and negative 1 is here. And then a and positive 1 are here. So we end up going like this. There's our reflection. Okay? Do I have that right in the right spot? I don't think I do. So negative, so 1 over a, negative 1 over a, up 1. Yeah, I think I got that right. This one is going to be a reflection again over the graph. So 1 over a is a and 1. So that's a comma 1. And this is 1 over a and negative 1. So this one looks like this. I think I graphed the first one wrong. Let's fix it. So this is going to be over a, up 1. This, the x and the y switch places. Yeah, I still think it's like this. Okay? All right, so domain and range. What's the domain of your exponential function? You're correct, it's all real numbers. What's the range? Those are your y values, and your y values are greater than 0. Your asymptote is y is equal to 0. So your domain for logarithms is all real numbers. No, they need to switch. Your x and y need to switch. So your x values have to be greater than 0. Notice we had answers that had ln of x is equal to negative 3, and we know that those can't exist. All right, so no, e to the x is equal to negative 3. Those don't exist. All real numbers is your range, and your asymptote this time is x is equal to 0. So these ones look like this, whereas these ones look like this or like this. So there's your range or your domain. Your range goes in both directions, and your asymptote is your y-axis. Domain, range, asymptote. Okay, so consider this function. And I'm not going to sketch it by hand, but you guys can look at it on a graphing calculator. You can also talk about it. How do I get this? Well, we have an inside number and an outside number. Inside numbers are your right, left, Outside numbers are your up and down. So the transformation, part A, is going to be right 1 and up 1. B, what's the new domain? Domain for logs is greater than 0, so it's just that piece, but it's been moved to the right one. So we're going to say our domain is x is greater than 1. Our range is still all real numbers. Even though it's been moved up, it's still all real numbers. Our asymptote, it's moved to the right one, so our asymptote is x is equal to 1. Axes intercepts, it normally intercepts the 0. It normally intersects at 0, so now it's going to intersect at 2, 0 instead of 1, 0. So sketch real quick. 1, 2. So there's your vertical asymptote. It's going to touch here, and it's going to go like this. And it's also going to go up 1. Sorry, I forgot about the up 1. So it's actually going to go, get rid of this. Oops. There's your axis. So it's actually going to touch right there. Okay. The inverse function, that's the math piece. So I'm going to switch my x and y for letter E. So this is letter D. This is letter E. I'm going to switch my x and y, so that means x is equal to log base 2 of y minus 1 plus 1. I'm going to get the y by itself, so I'm going to do x minus 1 equals log base 2 y minus 1. Change it into an exponential. 2 to the x minus 1 is equal to y minus 1. Add your 1 to both sides. Y is equal to 2 to the x minus 1 plus 1. So it's moved right 1 and up 1 as well. And that's what it would look like. So exponentially, it would be, here's its, would look like this. Okay. Questions? All right, so your assignment, again, I picked some problems, not too many, just some practice, some manipulation. So there's your assignment. You're going to upload 6G and 6H just like we have been the last 2 weeks. Here's the big additional piece. It is a quiz. It's 20 questions. I'll tell you that ahead of time. You can log into Schoology anytime Thursday or Friday. So Thursday at 12 a.m. So yes, Wednesday night when I'm asleep until Friday night at 11:59. This can only help your grade, especially if your quiz grade needs help. So if you look at your grading, the categories for your grades, most of your grade is based on tests and quizzes. So I'm going to try to, invent a few more of them to allow some of you to continue to bring up your grades. Again, please log on to office hours. Again, based on the school, my official office hours are Thursdays from 1 p.m. to 3 p.m. However, I will be online on Tuesday and Wednesday. If you need math help, I'm always online on Friday as well. You don't need to log in on Tuesday or Wednesday, especially if you need to go to your office hours for your other teachers. So find me if you need help. I hope you guys are well. I miss you. I'd love for you to log on to office hours just to say hi at some point in time.